Yes. So in our last lesson, we were looking at this velocity time graph. Okay, and I've told you that this velocity time graph, they have three different shapes. The first shape is going up, the second shape is horizontal, and the third one is coming down. Going up means acceleration, the velocity is increasing, and horizontal means constant velocity. The velocity is fixed, constant velocity. And going down like this means deceleration. The velocity is decreasing. Okay, so if we look at it from the grade for the from the slope, the slope is positive, acceleration. The slope is zero, constant velocity. The slope is negative, deceleration. So we look at it from the point of slope. And we also know another thing is the area under the graph. Now the area under the graph represents the displacement or the distance traveled during that period of time. Okay, so this is the area under the graph. So from 0 to 9 seconds, the distance covered or the displacement is represented by the area. From 0 to 10 seconds, the distance covered or the displacement is represented by this area. From 0 to 12 seconds is represented by this area. But there is one thing that I have not shown you yet. So what is it that I have not shown you? This one, right? Now, there is a possibility that the line that we trace, whether it's position time graph or velocity time graph like this, there is a possibility that the line can cut the x-axis and go down below the x-axis. Now, if the line is below the x-axis, what does that mean? If the line is below the x-axis, what does that mean?
Negative.
It is negative, but you see, for displacement time graph, the displacement is negative. For velocity time graph, the velocity is negative. Okay, so let me go through with you one more time. Okay, right. So we divide the graph into three parts. Then we talk at the same time we compare the three different type. So we see that for position time graph, the line is a straight line. The first part of the journey, we divide into three parts. The first part like this, then the second part going down, and the third part falls below the x-axis or below the time axis, right? So the first part, if it's a straight line, we identify the points on the line. The points on the line are 0, 0 and 9, 7. So 0, 0 and 9, 7, it means that time is 0, position is 0, time is 9 seconds, position is 7 meters, right? So these are the things that we can see directly from the graph without any calculation. Right? You can see directly. So we can see the points and we interpret the points. We interpret the points as time versus position, right? This one, the first one. Okay, the second one, which is hidden, we cannot see directly, is the slope of the line. So the slope of the line, I try to calculate this, the first part, okay, using the method for calculating, okay, 7 minus 0, 9 minus 0, 9 minus 0. So 7 minus 0 divided by 9 minus 0 is 7 over 9 and is a positive number. How do I know it's meter per second? Now the 7 here represents the meter. The 7 here is represents the meter. Is given by the y-axis, is a meter. Then you divide by another number 9. The 9 is in seconds. The 9 is in seconds. The 7 is in meter, the 9 is in second. That's why we arrive at the unit meter per second, right? So you just look at the vertical axis, meter, horizontal axis, second. So the slope will be meter per second. And it's a positive number. Now, what does this mean? It means that it is traveling with a constant velocity, right? And it is moving towards the right. Okay. Now, the second part of the journey, again, we try to see what is shown directly. So what is shown directly is the 2 points, 9, 7 and 10, 0. Now, what they represent? They represent when the time is 9 seconds, the displacement is, the position is 7. When the time is 10, the position is 0, right? This you can read directly from the graph, okay? So this is what, this is the interpretation of the point. But something which is hidden is the slope. So I try to find the slope of this line. How to find the slope? The final minus the initial. The final one is this point here, 10, 0. So I use 0 minus 7 divided by 10 minus 9. So here I have 0 minus 7, 10 minus 9. Now, if you have listed out the point like this, then it will be very easy for you to see which number minus or subtract which number. So if you list out the point, then you use the bottom set of numbers, subtract the top set of numbers. So you arrived at one number, negative 7 over 9. So negative 7 over 9, what is the unit? Then you refer to the y-axis meter, horizontal axis in second, so it is meter per second. Right. And this 9, negative 9 over 7 meter per second means what? It means that the object is traveling with a constant velocity, but this time it is moving in the negative direction. It means from right towards the left side, moving towards the left side. So at first it's moving towards the right, then they turn back to and go towards the left. So when they reach the extreme right, they will be instantaneously at rest. It's just like throwing a ball upwards. When it reaches the maximum height, it stops for a short, instantaneously, and come down again. So it go up, then the reverse the direction. So whenever there is a reverse in direction, there's always instantaneously at rest. That means it stopped for a very short moment, a short time, right? So after that, you reverse the direction. So the negative 7 over 9 shows that they reverse the direction. After moving to the extreme right, they reverse the direction, right? So, and they reverse the direction until it reaches the original position, 0. You go there, then you come back to the starting point. And if you go further from the starting point, you will see this point here, 13, negative 4, right? Now 13, negative 4 means what? Okay, so we look at the point. It starts from 10, 0 to 13, -4. So it means that from uh, time equals to 10 seconds, the displacement is 0. When the time is 13 seconds, the displacement is -4. It means that from the original position, the starting point, now this after coming back to the starting point, they start to move to the negative side. Why I know they started to move to the negative side? Because the x is negative, x is -4. So they start to move to the negative side. Now all along for the previous example, I have not shown you the negative position. So now I'm showing you the negative position. So from there, they move to the negative side. So you have this -4 there. Okay. I want to know the one that is hidden. That is the slope here. The slope you have to calculate. So -4 minus 0, 13 minus 10. Okay. So it's -4 minus 0 divided by 13 minus 10. So it's -4/3. Again, the unit is meter per second. Now, this negative means it is moving in the negative direction, moving towards the left, right? Okay, so you look at the top here, right? From 0 to 9 seconds, they are moving to the right, okay, with a velocity of 7/9 meter per second, with a velocity of this one, 7/9 meter per second, until it reaches 7 meters, until it reaches 7 meters. So after that, they turn back until the zero, the starting position earlier. Okay, they turn back and come here. Then from this starting point, they move to further left another 4 meters or -4 meter. -4 meter is the final position of the object. The numbers here, 0, 7, and -4, they actually represent the position, not the distance traveled. If I ask you how far they have traveled, no, the distance, right? The distance. So it will be 7, 7 going away, 7 coming back, then another 4 towards the left. So 7 plus 7, 14. 14 plus 4, it will be 18. So if you look at the distance traveled, you have to take the numerical sum, right? You just add them up. But if you want to look at the position, they are 0 to 7, 7 to 0, then from 0 to -4. So these numbers, 0, 7, and -4, they are not the distance traveled. They are not the distance covered, but they are showing you the position. Where is the object? Okay. So all the numbers that exist on this y-axis here, calling them position, is they are really position. They are not the distance traveled. Okay, they are really the position. Where is it now? Where is it now? It is not how far it has traveled. No, right? So the 7 here doesn't represent that it has traveled 7 meters. It shows that the position is 7 meter, is at the 7 meter. Now, finally, when they come back here, 0, the position here is 0. It doesn't mean that they have traveled 0 distance, right? It means that they are now standing at this 0 position along the number line. It doesn't mean that they travel 0 distance. But if they ask you for the displacement, yes, the displacement is 0, because displacement means what is the position. Displacement means what is the position. It doesn't mean the distance traveled. So that's why earlier on we study two physical quantity. One is distance, another is displacement. Displacement really is the position, right? It's not the distance. So all this what we have been calculating here can be shown by this can be shown by this thing here, right? This all this here, right? Can be shown by this number line here, right? So is can be, you can visualize what is happening, right? This is for you to see what is happening, right? Now, so far, you have any question or not? You want to ask me?
All is good. All is good.
Huh?
All is good. No questions.
No question. No question. Okay. Now, no question. Then I'm going to show you the